welcome to this. Uh, we'll be conducting a lot of free workshops and paid cohorts going forward. We'll get into details very soon. As of now, this session is streamed through both YouTube as well as LinkedIn. As highlighted earlier, you can actually join our meetup by registering if you already have account with Zoom. The link is already provided in YouTube comments as well as LinkedIn comments. You should be able to join from there. Today's host is me, and the speaker or guest speaker is nothing but Naresh. Uh, Now, first, let me give a brief walkthrough about what is ITVersity. So our mission when it comes to ITversity is make data and AI careers accessible via hands-on learning. And ITversity is known in the industry for almost a decade. It started as a YouTube channel, and we have trained thousands of data engineers across the globe through platforms like ITversity, Udemy, YouTube. Also, there's a lot of content. Last 3 4 years, we ranked down because I haven't taken care of SEO properly. But otherwise, it was the most prominent channel in big data space at one point, especially when Cloudera and Hortonworks are prominent. However, through Udemy, I have trained
So,
almost 400K resources across the globe, or 400K professionals across the globe. And we also have a state-of-the-art lab through which tens of thousands of people have learned big data and data engineering. Uh, Companies like Trendy Tech, Analytics Vidya use our labs. So we are known in the industry. Our Now we wanted to get into data and AI space, and we wanted to focus on a lot of free workshops and also paid cohorts. Uh, our focus will be primarily hands-on learning, uh, and also the outcome is career success. I want your careers to be successful, which means not necessarily just getting the jobs, but also be comfortable when it comes to delivery of your projects and see a growth over a period of time. The formats using which we are going to evangelize around data and AI are nothing but live workshops, guided cohorts, office hours, and also the outcomes are nothing but real life projects. Portfolio will help you building the portfolio, will create a healthy community, and also will provide you required mentorship. Now, here is the 2026 plan. We have very big plan. I wanted to scale up ITversity. So far, ITversity is solely run by me. I can say it is a solopreneur gig. While I'm consulting in other companies, I have spent time in creating the content and provide the training. But starting from 2026, I wanted to scale up. So yeah, in Q1 2026, I wanted to have a recurring cohorts every month. I wanted to start either a data or AI cohort. The pilot is going to start in October this year. So last quarter there will be a pilot. Already it is broadcasted, and we have quite a few enrollments, and we are on track to start the first pilot cohort. And then in 2026, on recurring basis, there will be cohorts around data and AI. On top of paid cohorts, we also wanted to conduct 50 plus free events and workshops. And this is first of its kind. Means in that series, this is the first. For the rest of the year, 2025, we'll go a little bit slow. But in 2026, we wanted to have more than 50 free events and workshops. And most of them will be online. There might be offline also, but most of them will be online. We also wanted to have a healthy community, and by Q3, we wanted to see a big community. Uh, we have set goals for ourselves, and we wanted to make sure we get into rhythm with respect to free workshops and events by Q2. And by Q3, we wanted to have a solid community. And by end of Q4 or starting from Q4, we wanted to focus on industry partnerships and placements. Okay. So that being said, the paid cohorts will be all the way from beginner level to advanced tracks. We are working on streamlining the cohorts. Rakesh from my team is going to spearhead that, working with even you can be part of that as a mentor or a consultant or whatever ways is feasible. Okay. So if you are interested, reach out to us at support@itverse.com. We will see how we can collaborate. The community will be primarily on Discord, and the events will be conducted through Meetup, and there'll be a Zoom meeting, and you will be joining the meetings like this. And also, the support will be provided through Discord, even for the content related to those meetups. Most of these meetups or workshops will be demo first and practical, and I'll get into a lot more details at a later point in time. Our focus will be, as I have mentioned to you earlier, projects, placements, and partnerships. 3P. Okay. Now, when it comes to paid cohorts, these are the ones which are in my mind at this juncture, but we are contemplating a few others also. We will take the opinion of you and also the industry experts seriously, and we'll plan for other tracks. For now, we are planning data engineering track using Databricks. Uh, Guys, don't get on to unmute unless uh, it is required for you to speak. And yeah, now let me proceed. Right. So I'm talking about the paid cohorts which are already in plan. They are nothing but data engineering track using Databricks and RAG or agent engineering track using open source LangStack ecosystem. And the structure of paid cohorts will be weekly live classes plus labs and capstones. And there will be a lot of assignments for you to master. And our emphasis will be on vibe coding, not regular coding. Okay. And we will tell you, groom you how to vibe code using right examples, how to validate whether the tiger is under control or not. Vibe coding is like a tiger or lion, and you should be a ringmaster, right? So you have to learn those techniques. To be a ringmaster, you need to learn techniques, right? Even for becoming a successful vibe coder, you should know such techniques where you can be the ringmaster and you keep the line under control. Okay. So our focus will be on that. And the deliverables are nothing but GitHub repos, deployed apps, portfolios, and so forth. Uh, Now let me go to the next slide. I think someone is not on mute. Let me see who is not. Yeah, I muted everyone now. Now let me go to the next slide. So as I have already mentioned, we are also planning 50 plus free events next year. There will be one-on-ones, there will be build-alongs, which means we'll build uh, applications together. One of the example is today's demo. It is not build along, but we will try to cover how to build a mini RAG app. However, when it comes to 2026, we'll also have like 4 hours free meetups where we will build something in 4 hours. Okay, and then we'll also discuss about tear downs by going through reference architectures and understanding what it actually means. We'll also talk about TCO, ROI. All these are concepts. 1 minute. Okay, all these are concepts to be successful in your career. Like TCO means total cost of ownership, and ROI means return on investment, right? So you will also start understanding this terminology. We'll also talk about creating your LinkedIn profile, creating your portfolios or digital footprint, study plans, etc. Those are categorized under clinics. Okay, so there will be clinic sessions. There will be product walkthroughs. For example, I have created this presentation using GenSpark, and we wanted to give a product walkthrough of GenSpark, what all products it have, how we can build presentations like this. So those are nothing but live features of products along with build along. It can also be an example for build along. Then bake off. So we'll talk about how we can use 2 to 3 tools and build something or bake something, right? And also office hours, which is nothing but live troubleshooting. For example, let's say you run into few issues. A lot of people might run into similar issues, right? So not only me, there'll be my team members and also guests like Naresh, or you can be part of it, and you will be able to take care of certain live troubleshooting sessions. Okay, so these are some of the formats using which we are going to conduct these meetups. If anyone wanted to be a speaker in these meetups, reach out to us. We'll definitely collaborate with you. Uh, then comes the RAG or Agent Engineer cohort, which is launched which is already launched as beta. It is starting in October. It is primarily for developers, data engineers, full stack developers, data engineers, and ML pros. And you will be learning retrieval, re-ranking, how to build agents, guardrails for testing, and also guardrails for controlling the lion, and then evaluation and observability to ensure the applications which you are going to build, or RAG-based applications which you are going to build, are actually built properly. Okay, so there will be two capstone projects. One capstone project while you go along the course, and other one towards the end. We are actually working with industry partners, startups, and all to come up with the problem statement so that you can actually build your portfolio if you are part of this paid cohort, which is starting in October. If you wanted to know more about this, you can actually click on this YouTube link, and I'll be sharing this after the session, and you can click on this. Or you can also reach out to us at support@itverse.com, and we will take it further. Okay. So this is how it goes. For first 2 weeks, we'll build a thin slice RAG, then we'll talk about ingestion, then how to get the data properly, then how to build agents using LangGraph, and then finally evaluate and deploy. So this is the timeline for the 10-week snapshot for the upcoming beta cohort, and this will be repeated starting from January. At least I'll be planning 6 to 8 cohorts like this on top of Databricks cohorts. So today I would like to introduce Mr. Naresh. I forgot to include the LinkedIn link of Naresh. Let me share it as part of this chat so that you can connect with him. And uh, for me, on top of working on these RAG-based applications, Naresh played a vital role to upskill. Okay. So he's a very important person for me, and it's a privilege for us to start our first session with him. And let me make sure I give the link so that you can actually connect. On top of working for a leading bank based in US as an executive, he's also data and AI practitioner, and also he help building careers through TopMate, and he haven't charged a penny so far, and he helped quite a few people in building careers through TopMate. In case if you are interested to connect with him, and if you are in Dallas, definitely you can plan meeting him, and you can take it forward. Yeah, Naresh also shared the link. Thank you, Naresh, and yeah, you guys feel free to connect with him and start exchanging ideas, or uh, start getting some knowledge from him. Okay, so here when it comes to the event, we'll be building a small or mini RAG application. Naresh will take over and talk about it. I'll be handing it over to him very soon. But I wanted to highlight what today's workshop is about, and how it is related to our course. So this is actually integrated with the course, and Naresh is also advisor for the course. Okay. So in today's session, you will be building a mini RAG app, and lot of concepts will be used in week 1 to week 5, where we'll be building a baseline app using LangChain, and also observability is taken care of using LangSmith. And after that, we will actually get into orchestration starting from week 4, but we'll be using this kind of application there also. And then after week 4, week 5, uh, going to the concepts related to the orchestration, we'll be building another application, and we will see uh, how to orchestrate these two applications as agents. Okay. I don't want to get into the use case at this juncture because we will be learning it as part of today's session. And all the resources that are presented today will be shared with you. Those who have registered in Zoom, we will actually send an attachment. And even those who signed up through Meetup, we will actually share the details. For LinkedIn, there is no way to directly communicate. So in case if you join through LinkedIn and if you haven't signed up to our Zoom session, uh, or if you could not join today's Zoom session, don't worry too much about it. Reach out to us at support@itverse.com, and we will provide all the resources. Okay. So that being said, now Let me hand it over to Naresh, and he will take care of running the show. And I'll be hosting. If you have any questions, don't unmute and ask the questions. You can actually raise your hand, or you can post the question in the chat. I'll take up that question. As there are enough people in Zoom meeting, the priority will be given to the questions in Zoom meeting. If time permits, I will also look into questions from LinkedIn or YouTube. However, going forward from next session, we'll only host through Zoom, and we'll stream to YouTube. And the meetups are actually conducted through our meetup group, uh, which is called as Online Data and AI Community. I will also share the link in the chat for your reference so that you can sign up through Meetup and you can get all the reminders and all through Meetup. Okay. 1 minute. Let me mute. Yeah. Yeah. Now it's up. You can take it up. Let me make sure I make you the. Let me stop sharing the screen first, and then let me make you host. Okay, I think I should not be making you host. Let me say 1 minute, guys. I will. Yeah, let me give access for everyone to share the screen. Let me see if I can only give it to Naresh. Okay, just give me a minute. Yeah, Naresh, now you can actually unmute yourself and start sharing your screen and take it further. If you have any issues, let me know.
Hey, yeah. Thanks, Durga. Thank you for this opportunity to be here and see this. I think this is a lot of community you built over a period of time, and I was one of the community member during the 2017-18. I learned a lot from the Durga as well, and from his Spark AI data engineering courses, like most of you done. Um, Having said that one, as you know that my name is Naresh. I'm working for a bank here in the Dallas area, where I'm responsible for the data AI analytics platform, building the um, applications around these AI, generative AI, and the data engineering. So today, we decided to build an application so that we wanted to cut the lot of noise that you are hearing in the uh, when you go to the any social media platform. Like every day, some people like every new day, every day some new model will comes up and people talks about a lot. But there are a lot of noise is there, and we wanted to get rid of that noise and share you the what is really required for anybody wanted to be an Gen AI engineer, or like you wanted Gen AI as your one of the core skill in your resume that will help you to build your career, like that get help you into those kind of projects and opportunities. Having said that, I'll share my screen and we'll go through today's agenda, what we are planning to do, and then we have planned a demo at the end, but we will first understand the fundamentals, and then at the end we will see those fundamentals in action in building an application. Okay, let me share my screen a minute. Hope you can see my screen, right? Please confirm.
Yeah, we can see our screen.
All right, yeah. So yeah, today's session name is building a mini RAG app using the one of the most used frameworks like the LangChain and the LangSmith. There are other frameworks like the Llama Index are there, but if you look at that versatility wise, the LangChain and LangSmith are the better compared to the others frameworks. So this is a practical implementation guide for you to build a real application, real world applications. So the today's agenda is like we'll understand. We'll start with what is an LLM. Then we will look into the what are the some of the challenges that LLM have. What are the strengths of it, and when it has a challenges, how we can override those challenges, and then how the RAG can help us to implement these kind of challenges, and then we look at the RAG architecture, a very high level, and then we look into the some of the components that make up this entire the RAG system. So we'll look into those, and then some of the concepts around those components, and then we will look into as I mentioned, we'll use the LangChain as a framework to build the application, and as well as we'll show you a LangSmith, how you can see the observability of your LangChain application, like the way you debug your applications with the LLMs. And then at the end we go to the demo, and I'll share a few more resources on some of the advanced RAG techniques. These are very limited, but there are a lot of other techniques, but these are some of the things I implemented in my work, in my POCs that I've been working so far. Okay, so we'll start with the welcome to the workshop, by the way. So, and then we'll start with the fundamentals of the LLM, and then we go further. So, LLM, what is an LLM? It's a large language model. In a very, very simple words, it is a application or a program, but that is more intelligent than our the application that we are seeing today. So with these these programs can basically understand the human language and generate the human language. So far we have seen an application, you give a certain question, like if you wanted get an output from a system or an app program, you give an input in a certain way, means like a programmatic way or like a structured way, right? But these LLMs, for them, they can understand your natural language as well as interpret your intent behind that your natural language question, and same like a human, they can generate the text. We as a human, we write and talk text, right? So these models can generate the text. So that's what these LLMs, and these LLMs are used for wide variety of tasks. These are the some of the like the question answering, summarizing. These are very limited, but there are a lot of other use cases around them. But when when we talk about LLM, most of the time we talk about the question answering, like RAG chatbot applications, or summarizing the documents. Like you have a research paper and you don't have the time to read the entire content, so that you give it to this model and ask it to summarize it for you. So, and sometimes translations. So these are some of the use cases, basic use cases. That's how the large language models started. But if you look at today's models, they are more advanced. They were able to reason, they were like reasoning like a human and take an action. So that's the concepts I'll call the agents. We'll go into the some other time, but for today we'll stick to the fundamentals. Hope that makes sense. What is an LLM? How many of you know the difference between a LLM and the chat GPT are like a group, right? So most of the times we see that one chat GPT is compared with LLM. So actually they are different, but they are together, they work together. So if you see if you see the bottom, this is an LLM, that's a language model, and the chat GPT, Grok, and the Perplexity, these are the applications they built on using these models. So there is a subtle difference between them. So the application versus LLM. So we need to have a clear distinction between them. Whenever you use, I think most of you use the chat GPT, right? You have a lot of models to select there. So the latest model GPT-5. So that's what the difference between a generative AI application versus an LLM. So hope this makes a clear distinction between the chat GPT LLM applications versus LLM. So let's talk about some of the technicalities of these LLMs. So I think it was in the around the 2017. the Google Research Lab, DeepMind, they released a first research paper on the transformer architecture. So that is a breakthrough in the NLP domain, basically natural language processing domains. So these most of the models, the large language models we are seeing today are built around the fundamental transformer architecture. So as an application developer, like a generative AI engineer, we don't need to know the details of these one, but I just wanted to familiar with that words. So this transformer architecture have a components like a encoder and decoder, and they will help you to get they'll help you to uh, uh, they'll help you to get the self attention as a capability. So self attention is a capability, is if we have to explain, is like when you read let's say you are reading a sentence. So let's take an example of a sentence like a cat sitting on a wall, and a cat sitting on a wall, the color is blue. So here, they, as a humans, if we wanted to understand, we look at the words cat and the wall and the color. So these are the three important words in the entire statement, right? So as a humans we can understand, but the machines cannot understand. So this self-attention mechanism is a technique that will help the model to understand most important words in a sentence and paragraph. If you don't understand, just leave it there. So this is some kind of capability that will help these models to understand our natural language queries. So just understand that it's a capability of these models. And these models, I mean, as a we can build these models, but these models requires a huge amount of data, and they require a huge amount of compute to build this application. That is why they call it the large language models, and some of the big organization can only afford that kind of human resource power to train those models, create the data sets. The model that the most prominent model to so far is the GPT-4o, that has an 1.8 trillion parameters. Again, don't worry about that. What is the trillion parameters? We don't need to worry about as an generative AI application developers. So these are something the technicalities of the model. So these are like knobs and switches. Like if you take any electronic device, right, you will have the knobs to adjust the functionality of these the electric machines, right? Take an example of the radio, so like FM radios, right? When you adjust the frequency, you will able to get it. You will be able to go to a different channel and listen something, right? So the parameters are like that, and the
So,
model.
so Naresh, there are a couple of questions. Let's take up these
Yeah,
questions.
sure, sure.
So Vijay is asking what is the token? I'll take it up. So Vijay, so if we start diving deep into all these, we'll not be able to complete in 1.5 hour to 2 hours, right? Especially for the concepts, what we are trying to achieve is we wanted to create shorts or reels. So we have identified almost 65 to 70 topics where we'll be creating shorts and reels so that you understand what is the token, what is RAG, what is the hallucination. So we are going to give it as the interview preparation toolkit for our students, and also we'll be broadcasting through our YouTube channel, Insta, so and so forth. So hold on to these concept related questions. We'll not be covering all those nuances in this 1.5 hour session.
Okay.
And Venkatraman is asking whether all these points are related to transformer architecture. So Naresh, can you answer that question?
Yes. So the transformer, these are all related to the transformer architecture. So
Yeah.
transformer is like the framework way of doing that, and each model coming up with their own version of the interpretation of those framework. So that's what all these related to the transformer architecture. to your
Okay.
question.
And Mr. Gupta is asking, are we going to cover MCP also as part of building the RAG applications as part of the paid cohort journey? Me and Naresh are contemplating around it. Okay. And we will either it will be part of the 10-week program or we'll have an advanced module on top of it. So we'll get back to you on that. But as of now, for the beta program, it is not part of the 10-week. However, we'll be covering LangStack and we'll have the uh, RAG-based applications built and orchestrated, so and so forth. Okay. So we'll get back to you on MCP. And Shivam is asking, okay, Shivam is answering to uh, uh, Vijay. So Shivam, you are up to an extent correct, but it is more to it. Okay. And yeah, so it's a good idea. We'll get into Q&A towards the end, but you feel free to ask questions. Depending upon the context, I'll curate and make sure I ask these questions at the right time. That will actually be a better experience rather than pushing all the questions till the end. So,
Okay.
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 So that being said, let's proceed, Naresh.
Yeah. Yeah. So these are the, as I mentioned, like these are related to the model. So we don't need to know, but I just wanted to familiar with that. So these words so that you don't get confused. Okay. So I think you are asking about the token, right? Just I put a very high level things about the token. So token is like, let's say you took a word like a large language models are so powerful. So when you tokenize is that you break the text into a words, so the words of different length, so that's what the tokens you see that large language model, these are the different words. So an approximate like a one token is like 4 characters in your text, so that's what you can assume that, but these are not the hard rules, but approximately that's what the token. Okay. And the here we mentioned like the 128,000 tokens is like that is the amount of text you can give to a model when you are asking a question. So that's what the token length. So this is what they call it as a context length also. Like when you are asking the chat GPT, you are writing a question, right? So the question length should not be more than these question or content that you are providing should not exceed these many tokens. But if you convert this is a very big documents, you can send it to the LLMs. Okay, having said that one, so some of the use cases, I think we covered this one, like we use for the content creation. Some people are using for ideation as well. And most of this service, most of the companies, they are using they are empowering their chatbots with generative AI capabilities. So that's another use case. And most of the times I use for my education and learning activities. Like if I get some research paper, I don't have time to research everything, so read everything, so I use the LLMs to help me to quickly understand the essence of those documents. So these are the some of the use cases for it. There could be more, you can come up with some more use cases. Okay. So we saw that one LLM has a so powerful, but with any system that has so powerful, they also have certain kind of limitations, right? The LLM also has certain limitations, like they are the main limitation. I would say that an out of date information. So they do not have any latest information happen. So they do not have information about yesterday what happened or a 1 month back what happened. So that's another challenge with the LLMs. So other challenge is that if you observe that one, if you use the chat GPT, I've been using the GPT for some of the work. Sometimes these models will generate the some kind of information that is factually not correct. So that's what we call hallucination. And the latest models, the GPT-5 giving a lot of hallucination for same reason. So it's basically what it means that even though it don't know the answer, it answered very confidently. So that's what the hallucination. We see an example for it, how one of the models giving a hallucinated information. So, and the big challenge for this organization is that these models cannot answer the question related to their organization. If you are working in a finance, you ask something related to your company specific words or vocabulary, it may not able to answer. That's an main another disadvantage with these LLMs, even though they are powerful. And the other disadvantage is that citations. So whenever you ask a question, these models, they are able to generate an answers confidently, but how do you know that this is the correct answer? You should have some kind of reference material to show that, right? To get a confidence on that the answer generated by these LLMs is accurate. So these are the predominant limitations of these models. There could be more, but these are most of the times we see these are the issues we see in any enterprise settings. So then how do we solve these challenges? So that's what the today's agenda. So we will go into cover that as part of the RAG. So as I mentioned, like in the previous slide, so outdated information, they don't have the information about what happened yesterday or day before yesterday. So if we go and see one example, like this is a chat GPT screenshot, I took it. So I was asking the GPT, what was your latest cutoff date? It was saying that its latest cutoff date is June 2024. GPT-4 model, June 2024, the cutoff date. If I ask something happened yesterday or day before yesterday, it may not able to answer it. It may give an answer confidently, but it's not factually correct. And the same thing with GPT-5 also. Its own cutoff date is June 2024. So basically what it means that they were trained on the information up to that date so that they can answer any question up to that date. They know the knowledge up to those many those dates only. So that's what the cutoff date for this one. So this is what the limitation with these models. So they don't have the latest updated information. And I just ran one simple query, like if you follow the geopolitics, recently Trump and Putin met in Alaska. So I was asking the model, the GPT-4o model. So I was asking where did the Trump and Putin met? And it was giving some information saying that they met in the 2028, but that's not true. The latest information is like they met in last month. So this is an example for an outdated information. Okay. So the second, the challenge besides the hallucination. Hallucination is basically giving an answer without, I mean, it's not factually correct. So that's what that. So basically, the hallucination is a very big challenges in enterprise settings because that basically erode your customer trust. Because you let's assume that you build a bot and that it's giving an information that is not factually correct, then the customers or users will be think that one the trust will be lost, right? So the trust is a very very important for any organizations to succeed. So that's a one challenge for with the hallucination. And let's say there is a highly critical domains like the healthcare and legal or finance. If they give an information that is not factually correct, that will have an implications on the organization. So the hallucination is a big challenge for these models. Okay, so that's the second challenge. So and again I'm asking, I went to the this time I went to your DeepSeek models and I asked the like what was the place, the asked the same question in the previous slide, and it was giving some information about that meeting happened in 2023. It's not the true. The latest meeting again happened in the 2025. So if you see that one, it's not even saying that you this information may be outdated. It's confident. It look if you by looking at somebody who don't follow the news, they will think that okay, maybe they met really around 2023. They never met. So this is an hallucination, right? The model, because it's don't have the information, but it's trying to tell that one the old information. So this is a way of hallucination. So then other challenge is like if you go and ask your these models your company specific information or like your company specific like internal information, they may not able to generate an answers, give an answers for you. So you are asking like let's say you went and then you ask this model what is the leave policy in your organization. This model may not know that one because the leave policies are internal to your organization, right? So if you see in this screenshot, I was asking like What was the approval workflow in the onboarding a new employee in the Tesla? Like any organization have an approval workflow to on new employee, right? It was saying that I don't have any access to that specific internal process. It is little bit clever. It was saying that I don't have it, but it's saying that it can give general information. So this is again, it's not these approval workflows or the onboarding process are different for the different organizations, right? So they don't have the information to answer them. So that is another challenge, the third major challenge with these LLMs. Um, so again, the other challenge is that whenever they are generating this answer, they are not giving any information about I am referring this specific document to give an information. So that's what they call the citation. They're not able to cite that information, how they came to that, know how they are able to give that answer. So that's another challenge. And as we saw in the in the first challenge is like updates, right? So if you have to update these models with the latest information, you need a lot of compute and resource powers. So that's again another disadvantage with these LLMs. So they don't basically, so if they can provide this citation, we can feel that okay, these are referring the right documents to give an information, so that the customer trust build on the models, but it's not happening today. So that's another disadvantage of these LLMs. Then how do we solve
Yeah,
this one?
Naresh, sorry to interrupt you. So
Yeah.
one of the feedback is the images are small. So if you can zoom in when you are
Oh,
talking about, means I think we have already passed the issue.
yeah.
But in
Okay.
future, if there is any image which is small,
Mm.
it's better to zoom in. Okay, just
Yep. Yep.
okay, yeah, you
We'll
can.
make it. Yeah.
Yeah, yeah. So there are quite a few questions around RAG.
Mm.
Uh, all of them are uh, either answered if it is generic question, but some
Mm.
of the RAG related questions will be answered by the end of the session. So those who have asked the questions on RAG, if your question is still valid by the end of the session, you can ask follow-up question and we'll take it forward. Okay,
Yep.
because RAG is not covered, you guys might have questions, but they will be answered very soon.
Yeah.
Okay, go ahead, Naresh. Yeah.
Uh, yeah, so these are the we so far we discussed about some of the challenges with these LLMs, right? So the one way to solve these, I mean, as of today, the only way to solve these challenges we discussed so far is the RAG. So the RAG is basically we argument means we give that information to these models so that they will give a more trustworthy answers, reliable answers. So that's what the RAG. We'll get into the details of it. So why the why the RAG is important? So let's understand why. So if the if if you want your models to give a most verified accurate information so that users can believe on the application you built on top of this LLM, right? So that's one of the reasons the RAG is very important. Also, sometimes you wanted to control on the information that you are giving to your clients or consumers. So sometimes you don't want the certain things to be answered, like they are trying to break your system, like the bot, the chat bot, and try to get some kind of your company specific information to retrieve. You wanted to control like how to generate an answer when you ask the system. So that is also you can get the great control using the retrieval augmented RAG technique. We'll see that one, how we can control that one. So basically, you improve your accuracy and reliability of your system. And also, whenever you generating this answer, you wanted to see the how I generated this answer, like the citation challenges. We saw that, right? So we can solve the citation challenges with the RAG technique. So these are the some of the reasons for your RAG to be very important framework to build an applications around that one. So basically it will build the trust on your applications, or you they can give a most reliable up to date information. So these are the some of the challenges for the reason we implement the RAG. Can I take one question? I saw it in the chat, Durga. So someone is
Sure, sure.
saying that
Yeah.
they asked a question in the LLM ChatGPT and giving that information. So I wanted to take back to this one. So do not confuse with ChatGPT with the model. ChatGPT is an application. So the ChatGPT is powered to search the internet and give that information to the LLM so that you are able to generate that answer, right answer. So what we are talking about, these are plain LLMs. As a ChatGPT, you cannot use it in your organization or building your any application. You can use the LLM. So that's a subtle difference between the ChatGPT versus LLM. We are talking about the LLMs, how we can use this LLM, build our application related to your organization's requirement. So business use cases.
Yeah, let me add to this, okay?
Mm.
So ChatGPT is also an example for RAG application. Okay, what it is doing is on top of getting the information from LLM, which is cut off as of June 2024, it is doing web search. And then based on the web search, it is actually uh, uh, retrieving the data using web search and then augmenting and generating the response for you. Now, if you have the premium version, you can customize the settings. I think it should be there in the free version also. If you disable web search in your Chat GPT app, then it will not do the web and it will not be able to give the correct answer. Okay, so just keep that in mind. Chat GPT itself is an example for RAG application, which is not only using LLM model as of today GPT-5, it is also adding another layer of software or application which will take care of web search and provide you the uh, current uh, current answer. However, as Naresh mentioned, most of the organizations they don't give access to ChatGPT, but they give access to GPT models. And using GPT models, when you ask these questions, you will not be able to get the answers from web search, right? That's where you have to build additional applications for your organization needs. If it is relevant to your organization's data, then you have to take care of looking up into your database and get the results, or you have to, depending upon use case, you might have to come up with a solution and take it forward. Okay, yeah, go ahead, Naresh.
Oh, okay. All right, guys. So that's what the one of the why the RAG is important. So trustworthy, reliable, accurate information you can give to your users when you build an application using the LLM. So the if we demystify the RAG is a retrieval augmented generation. So the what's it will saying that you basically retrieve the information, you augment the knowledge of these LLMs, and finally you generate an answer. So that's what the RAG definition. So it's a technique that combines the retrieval with the text generation, allowing the models to get the most have the most relevant information when answering your questions. That's what it is, a RAG. So there are a lot of combine it's basically a two-step process like the retrieval has a different techniques to get a right information. Generation has a different techniques to generate a most accurate information. That basically means you can control the output generated, that one. So that is what the RAG. So think of like, if we have to think like a normal, like if you take in a detective, what they will do, that one they will get first, they will get the clues, and then they will put a story around those clues, right, to resolve a challenge. So that's what the RAG. So you get an information and then you generate an answer at the end. So that's what the RAG means. Okay, so let's look into the architecture of a typical RAG application. So if you take any RAG application, they are mostly the built on only this is the architecture. So where you have in a documents that your company or organization specific document, you take them and you give to a special model that will take this document and then convert into a certain numbers we call in a vectors, and then we store it into the vector databases, specialized databases. So that is concludes the first step of storing the document. When the user, as a user, when you ask the question, you again take that question, you give it to this model, and you again convert into a numbers, and then you give you search on your vector database, and you get some kind of similar documents. The numbers, you can follow the numbers. You get a similar document, and you give that similar documents uh, with the similar documents with your query, the actual query, and you give it to the LLM, and the LLM will generate an answer, give it to you the response. So this is the very, very simple, simplistic way of a typical RAG architecture. So there are a lot of, I mean, there are different ways you can implement to do this search. There are different ways to generate, extract the similar documents. There are some, we'll see some of those techniques in today's demo, but very high level, this is the way the RAG works. Hope this, the steps are clear, right? So we are going to go in detail into the each one of these steps in the coming slides. Okay, so if we break that this diagram into the different phases, so here is we have it like, so there are several key phases. So the first one is the data ingestion. So this is where we start, like we take the documents, we collect the documents that we wanted to process. So the second step is like these documents are very big, right? We cannot give these document as is to the model. So we need to break them into a small parts so that we can give the small parts to these models. So that is what called the chunking. It's breaking the your entire document to smaller manageable pieces. And then the next one is then embedding generation. Like as you see in the screenshot, you give this to the embedding model and it will give some kind of embedding. So that is what the embedding generation. So the embeddings are basically a numbers of your text. So if you take any text, when you give to the model, it will give the some floating point numbers. So that's what the embedding. And we take them and then we index, we store into the database, a data store. So that's what the vector indexing. And the next one is the query processing. We ask the question and we get the information from the vector database. That's what the retrieval. And then we augment that information with the retrieved, we augment that retrieved information with the question. So that is where it will go to the LLM to generation. So these are the very high level steps in phases in building your RAG application. So here here is another way of representing the same information. So that way you will understand. So you take the documents, tokenize it. That's what we heard in the beginning words. And then we break it into it, embed it, vector, we store into the vector database. And this is then a retrieval phase where user asks the question, you retrieve that information from the vector store, and then finally you give that information to the generation. So generation steps where it will go through a certain steps like the prompt creation, language model, and then it will generate. So it's the same flow of that we saw in the previous slides, but if you divide into the phases, this is how it looks like. So we heard about the chunking in the previous slide, right? So chunking is basically breaking the your entire document into a small part so that you can give it to the model. So there are various techniques that will help you to chunk it. So these chunkings, there is no thumb rule to say that you follow this chunking strategy for this use case. These are all some kind of experiments, you can try it out. So the some of them, one of them is a fixed size chunking. This we will see it in one in the demo, how we can break the entire document to fixed chunks. And the other is a semantic chunking. So don't worry about these words, just remember that chunking is like breaking the big document into the small documents, and there are various techniques to do that one. These are the some of the techniques. So you can that's just understand that these are techniques to break the big document to the small document. So we explained, right, in the we, as we mentioned, like the detective and storyteller analogies. So we get the documents and then we generate using the generator. That's what the storyteller. So this is what so very high level, the two-step process, the retrieval and generation. The ingestion is an offline process, so that's you do it in the one time, and then you have the data stored in your vector store. You typically, when you run the RAG up pipeline, you just do these two steps, like you retrieve it and you generate an information. And so we looked at so this is a process. So if we look at the RAG, there are various components, right? So I try to put it here, like we have the data, that's your organizational data, that may be a databases or APIs or documents. You have a vector database that store the documents in a numerical format that will help to search, quickly find your the data related to your question. So because of the numbers, we were able to generate retrieve the document very quickly. And the where RAG has a retriever component, so where you search it, right? Like if you take a database, you fire in a SQL query, right? SQL query is like your retriever, right? So that's what the retriever. And once you get the documents from the vector store, you wanted to prioritize. Sometimes you don't. Let's say when you ask the question, assume that you get a 10 records. You feel like the some of the records are not relevant. If you wanted to prioritize, if you can prioritize that information which is important, which is not that, so that is what the re-ranker. So that another way you can generate a more relevant document to answer your questions. And the final one is a generator. We go into the details. So before that, let's try to understand what is the prompt. Prompt is like when you are asking the GPT, right? You ask a question, right? That's what the prompt. So in general, we ask the question, a direct question, but in when you ask these LLMs, you can ask them to act like a certain way. Let's say I'm asking some financial question, so then I can tell that to the LLM, saying that you act like a financial analyst to answer this question, so that it will act like a financial analyst to give an answer. So that's what called the prompt. We'll see a prompt example as well in our demo. So it's basically the prompt is a technique you can give it to the model in such a way that telling it to how to behave it while answering your question. So that's what the prompt. There is a prompt engineering, like the prompt engineering these days. A lot of people are coming up with a different innovative ways of writing the prompt so that the models works in certain way. As I mentioned, the external data is like your documents, databases, APIs, where you have the text document or like the images or charts, visualizations. So that's what the external data in your RAG. On that external data, you wanted to answer your questions using the RAG system. So that's what the external data in the RAG. So the vector embeddings are like, as I mentioned, right? These, when we are asking the question, we are giving the we are typing in a natural language, the text format, right? But these models don't understand the a text, natural language text, right? So they understand the numbers. So that is what these vector embeddings. Vector embeddings, just assume that it's an array of numbers. So that's a simple way to understand the embeddings. These numbers used by these models, behind them, like they have a neural networks, the transformer architecture, they will understand these numbers and generate an answer. So here is I try to give an example, like let's say here is an example. The movie name is The Conference. So if you see to the right, I have a numbers, like we converted these horror number and moving into a certain number. So this is in a way, these are the not the actual numbers. You will get it when you embed it, but for our understanding, I put it like, so horror is converted to the 1.2. 2023 is a number is as it is. Movie is converted to the 20.0. And if you see the second example, the it is also have a horror, right? So it's again converted to the 1.2. So this is how the like for each text there is a number generated. So that's what the numbers are called the vector embeddings. So here the first word in this vector embedding represent the genre of the movie. So that's a way we can understand that. In a simple way, if you have to understand, embeddings are the a floating point numbers, numerics. That's it. I mean, that's what you need to understand as a Gen AI developer. So we need to, because we never interact with those numbers, because we never try to understand those numbers, because the model will use those numbers to understand the intent of your question. So the next component is in a vector databases. So we know so far we saw the relational databases or the non-relational databases like a HBase and all, right? Vector database, these are the specialized databases. They store these vector embeddings, and they have a certain capabilities like a semantic search capabilities. So they can these databases allow you to store huge amount of the information in them, and they will help you to quickly retrieve the right information, right documents, the text documents from the database. Those are relevant to your question that you are asking. So here we are taking the text, we are converting to the embeddings. That's the vectors. You see the numbers. This is what the embeddings, and that's they stored in the specialized database. That's called the vector database. We have we have some specialized vector database, and the existing database also we are supporting the vector support, but we'll see it in the next slides. So here is the way like how we are converting, like we are taking the document, we are giving to the embedding model, and then we are generating the numbers. Those will go to the vector database. That's what this one. So this is what we saw in the first slide in the RAG architecture, right? I think step number 1 and 2. Take the documents, store into the vector database in the vector representation. So there are a lot of vector specialized vector databases, and the existing database also coming up with their vector support. So the some of the most prominent vector database I used so far is that Chroma. Chroma I use for most of my prototype POCs, and Pinecone. This is another database that supports the vector enterprise use cases. And some of the existing databases like the Postgres, MySQL is also coming up with the vector support capability, so that you can have a single database to do the both the relational database stuff and the vector like vector functionalities that you can build your generative AI applications. And some of the NoSQL database, Mango and Elastic, also are supporting these functionalities. And these cloud data platforms like the Databricks, Snowflake, big queries, they're all trying to. Everybody is trying to have this vector capability in one place in the existing infrastructure, so that they don't need to switch between the different databases. But so far, I see that these databases, the previous databases, they are not the good as the specialized database of the vector. Yeah, the Chroma is the open source, and the Pinecone also has an open source version as well as the. I think both of them has both the enterprise version or the open source version. Depends on your use case. You can pick them. So the other component in the your RAG is a retriever component. Like you get a retriever from your documents, like when you have the data in your vector store, how do you get the document? How do you get them? Like, so the retriever is a component help you to do that one. So there are various retrievers depending on the database you are using. So we'll see the one of the retriever with the Chroma, how we can retrieve the information from the vector database using those retrievers. Is like retrievers is like an SQL queries for if we can relate RDBMS SQL queries for your retrievers. So the next one is the re-ranker. Re-ranker is like, let's say when you ask for a question, you got a 10 documents, and out of them, um, the last two documents are more important than the previous one, rest of them. So then you can use that one, like you can uh, arrange them these documents in such a way that you always have the most important document in the top and least priority documents in the bottom, so that you can ignore them if required. So there are late lot of re-rankers available. So re-rankers is like the Cohere has a re-ranker, that is one of the prominent one, that is that will re-rank your documents before you give into the final LLM. So and other so these re-ranker basically they use a technique called the RRF, reciprocal re-rank function. So basically they will arrange these documents in certain way so that the most relevant documents will become in the top. So that's a technique behind this re-ranker. And the final component is the RAG, the generator, where you give your the retrieved documents and your question so that the generator will generate an uh, answer to your question. And see these external databases, external data, right? So whenever you change your external data, you need to reindex them every time, because when your information get updated, that needs to be indexed again. Then only you will get an most relevant information. So these vector databases are coming up with the support for the CRUD operations, updates, deletes, and all, so that you have to continuously do these updates in your RAG systems to get you to have the most up-to-date information.
Yeah, Naresh, one question is yeah,
Mhm.
just for the confirmation, does Pinecone have a open source version or is it only paid?
I believe it's an open source. They have an open source version to play with, uh, play with to get a feeling of it. Maybe on top of, maybe I may be wrong. Maybe you can fact check. You can go and
Sure,
check that
sure.
one.
We'll
But
we'll
as far as I know, because any vendor they're coming out, they definitely give a version to try it out. Uh, Otherwise, nobody wanted to pay, right? So they will have an open. So that's what my understanding. Maybe I may be wrong. Okay. So having said that one, but the even if you see the okay, coming back to this Chroma, they have the open source version as well as the enterprise version. So I think that's a model they most of the any product will work today's market. Okay, having said that, coming back to that the RAG application, right? We so here we show I try to give an example of how the typical chatbot applications you can build on top of this RAG. So you take a user query, you give it to your chat app. That's a user interface. That user interface will forward the query to the RAG system. RAG system will retrieve the information and give it to the LLM, and LLM will generate the response to you. So this is the typical flow of building any RAG application, any chatbot using the RAG. Okay, so the flow goes like user send the query, chat application forwards to the RAG, RAG will generate the answer and give you the response. So that's what the flow will try to explain here. And let me skip this one. These are the a little bit detailed information of this flow. You can read through them when we share these slides. But I wanted to cover there is a one aspect of RAG versus fine tuning. So we might asking like, we know that these models are trained on the information. So we might ask like, why can't we retrain those models when the new information get it? So as we know that the retraining or the fine tuning is a very expensive operations, like because they need a human resources as well as a compute resources. So that is the reason most of the organization prefer to have a RAG as a technique to resolve this outdated information instead of the fine tuning, because the fine tuning is in a computing resource extensive operation. And the fine tuning is requires a specific, you need to prepare your data in a certain way to train those models. So that's again the resource intensive task. You need to put a lot of data labelers to label this data. So that's another disadvantage of fine tuning. And the adaptability is like, so adaptability, so let's say you have model trained on some finance domain, you wanted to use it in a HR domain, so you can do the fine tuning, but with it is requires a lot of domain specific information to build that one. But with the RAG, even though you model trained on a specific domain, you can guide it to give an answer for other domains. So that's another advantages of the RAG over the fine tuning. So, and these fine tuning requires to understand the internals of these models, mm, behavior like the parameters, labeling, all those things, architecture. Like there is an architecture called the mixture of expert, chain of thought. There are different architectures are there. So we cannot achieve all of them. I mean, as a application developers, it's overwhelming to do all those things because there is specialized engineers to do that one, researcher, data scientists. So we prefer to leverage the existing application and build something out of, give a value to our consumers or the clients. So that's what the RAG versus fine tuning. So maybe if you go in an interview, a lot of people will ask these questions, why you go for the RAG instead of the fine tuning. So this is a guide to answer why the RAG versus fine tuning. So this is like as explained, like with the benefits of RAG is like you don't need to spend any resources, and then you can get a minimum with the minimal changes the best value out of it, the existing models. So that's the reason the RAG shines over the fine tuning. And this the RAG is like, if you fine tune them, you cannot tell that one whether it's generating the right information, because there is again the missing the part of the citations. But with the RAG, you can cite the source. This is the information used to generate an answer. So that's a major uh, that is one of the feature you get out of the RAG, so that will help you to build the trust on the applications, the users or consumers. Okay, some of the advanced use cases is like, you can build the chatbot. That's what the conversational AI. This RAG application can be used for building the conversational AI, or like the question answering systems. And also you can generate the content generation or summary, like you can give it to the information, the document that you have it, and then ask it to summarize it for you. So these are the some of the use cases. And healthcare, it's not only healthcare, for any domain, like you wanted to understand the research paper, or what are the latest new new things are coming very quickly to read them. So health, some of the domains using this RAG technique, because for them these domains like the finance, healthcare, like the legal department, so you need to have the facts, right? So RAG is the fact mechanism that will help you to, while generating answer, will give you the facts. Based on these facts, I generated an answer. So these are some of the applications of the RAG. And the today so we before we get into the demo, so let's me introduce some of the components required for this to running these your labs. Lab are the notebooks. So you need an OpenAI keys that you can get it if you first time signing up. You will get a $5 from the OpenAI, so that you can use that. And then you need a LangSmith keys. So the LangSmith help you to do the observability and debugging the failures in your uh, applications, generative AI applications like the RAG, and you can run it on either in your Google Colab or local Jupyter notebook environment. These are the three prerequisites required for you to run this demo. So a quick introduction about the LangChain, and Durga will cover in the course in detail about this LangChain, but here I just wanted to give a sense of it. So the LangChain is an open source framework that helps you to build the LLM powered applications, like the model powered applications, like software applications. So it will have a lot of components like memory management, retrieval system, interacting with the various databases. So these are all you can define some kind of workflows. So a lot of the building blocks required for building any LLM applications you will get out of the box. You don't need to code. So that is the reason the LangChain a lot of people are using to build their application. And
Yeah, sorry to interrupt you, Naresh. So, guys, as we are heading towards the demo, I wanted to emphasize a few things because people are asking whether they will be doing anything live in this session. Due to time constraints, we will not be doing anything live in this session. However, we understand for a lot of you guys, this is not a comfort zone and you might end up running into issues, right? So how to best utilize everyone's time is by using Discord. So going forward, we are going to build a Discord community where all your questions will be answered, whatever is relevant for the offerings we provide. So in this case, I have shared a couple of links. The first one is Discord community. You need to sign up for Discord and join the community. And then second one is the channel for the support. So this channel can be used for all free workshops, not only this one. So in case if you have any questions or if you run into any issues while you practice, or if you have any clarifications required, you can post in the channel and we'll attempt to support as much as possible. I am building a support staff, and the support staff will even get on to one-on-one calls through Discord, and then they will provide required support. And if they don't provide the support, you can always escalate to me. So I am a L2 or L3 support. There will be L1 support guys, L2 support guys. If they don't sort out your issues, you can reach out to me. I'll ensure that all your issues are resolved in timely manner. That being said, we'll pause for a few minutes, for like 2-3 minutes. Make sure you join the Discord community and also the channel, and then we'll resume again.
yeah, as well as maybe we may little over 5 minutes. Please bear with us because I wanted to show all the things so that you will get out of a good learnings out of this. The concept we learned so far. Hope that is fine with everyone.
Yeah, we are running a little bit over time, but that's fine. Means I think the session is going very well.
Mm.
Um, we'll just I just want to make sure your issues are also supported without any gaps.
Yeah.
That's why I wanted to introduce you to Discord. Sorry for the distraction. While it is going on, let's take few questions which are asked by
Yeah.
Venkatraman. The
Sure, sure,
questions are very, very relevant and important. So, Naresh, I will ask the questions and you can answer. Just give me a minute.
sure, sure.
Let me pick those questions. Okay, so uh, and one more thing is Shivam, thank you very much. I think you are quite knowledgeable and your support is really appreciated. And your answers are mostly correct and accurate. I think you already seem to have experience. we'll see how we can collaborate as well. Okay. Now let me. So Satish have asked, can we have web search as part of RAG?
Yeah. Yes,
Yeah.
we
So
can
I'll
have.
answer that question.
Yeah.
So Satish, that's where LangChain comes into play. You might end up building different types of functionality. It could be an API call. It could be a vector search, such looking up into the vector store. It could be LLM call to make it conversational, right? So there will be sequence of API calls or function calls which we need to make. That's where LangChain comes into play. We can say chain of APIs or function calls to take care of giving you the response for your prompt in conversational manner. That's why they named it as LangChain. Okay. I think I have answered the question for most of the people who have doubts around it. If you guys have any questions around that, feel free to ask. We'll try to respond. Okay. I think we can proceed, Naresh.
Okay. Yeah.
Yeah.
Thanks, Durga. All right. I hope everyone joined. So coming back to the LangChain is a framework that will help you to give a lot of building blocks for building an LLM powered applications. And so again, the LangChain, why it is like, because it has a lot of integration with all other models out there, both the proprietary open source models, and they have an fundamental blocks to interact with them, so that you don't need to code everything from the start. So you can start building that. It's like any other framework, like you use the Spring Boot and all, right? You don't write all the code, you use the frameworks out of the box to build your application, right? So the LangChain is also the same way, but those are designed for LLMs, large language or generative AI applications. So the LangSmith, this is a debugging or a observability platform where whenever you are running your applications using the LangChain, you wanted to see that what is happening, how many times you are calling the LLM, what you are getting from the LLM response. So those visualization, like the visibility into those things, you can get it from the LangSmith. So just understand that LangSmith is an observability tool or platform for LLM applications. And as I mentioned, LangChain to build the applications, LangSmith to observe, optimize your LangChain application that you build, generative AI applications. So these are, the combination is so powerful, so that you can in any enterprise settings, you definitely use these two components for building generative AI applications. The LangGraph is an extension of the LangChain. This help you to build the multi-step workflows or agents. That's a more advanced concept that help you to do that one. We'll try. Durga will give the more details as part of the program, but this is the next version of the LangChain. LangChain means on top of the LangChain it was built. The LangChain still there. LangChain, the fundamental blocks are there. You can use those fundamental blocks to build the application, but the LangGraph is designed for certain use cases like the workflows, agents. So if you see the LangChain ecosystem, this is how it look like. So in the bottom part, we have a LangChain. This is an open source one. LangGraph is also open source one. So these LangChain have a lot of integrations with the other tools like the models. Those it will have an integrations, and they have an like you can deploy your LangChain application into the LangGraph platform, so that you don't need to deploy it in your cloud or in your local as well. So that's what the LangChain ecosystem is designed. So you see that one. So these three these three are the open source, but the LangGraph, like the LangGraph platform is in a commercial one. We need to pay for it. Okay, we'll see that when we'll run our RAG application and then how it's showing in the LangSmith. We can see the debugging our application. What are the prompts we are sending to the model? All those things. So this is a summary for you. LangStack, I think this Durga invented LangStack. This is a good name for it. And this is a LangChain ecosystem. So LangChain, LangSmith, LangGraph, LangServe. So these are all these components, core components of the LangChain ecosystem or LangStack. So let's get into the exciting part that we are talking so far, like building in a RAG applications. So we have some advanced techniques. I'll cover them once the demo is done if you have the time. But let me simply jump on to the demo so that you can see the mm, how to build a mini RAG applications.
Yeah,
Let me
while Naresh is getting into the demo, there are quite a few questions about the resources. So we'll be providing a notebook which you can experiment and understand hands-on. And also we'll be providing both the decks, the deck which is presented by me and also which is presented by Naresh. On top of it, we'll also provide the PDFs which are being used for the demo. Okay. And then we will take it forward. So Naresh, let me first emphasize about the use case which you are going to use, and then you can get into the demo. I think it
Yeah,
will
sure.
make more sense for them.
Yeah.
Because you are tired a little bit. I want you to relax for some time before getting into the demo. Okay.
Mhm.
So that being said, let me share my screen.
Mhm.
Yeah. Now you can see the screen, right? So we are going to share this zip file with you in email. So after this session, most likely I try to attach to the Zoom directly, but I think before starting itself, I need to uh, take care of certain settings. I'm going to do that. For that reason, after the session, we will try to share the zip. In Discord, we'll do it immediately by end of the session. But in the email, we'll send later. Tomorrow, probably we'll send because it's already late in the night, right? But we'll share it in Discord in appropriate channel, which is nothing but workshop support. You can see workshop support. So most of you have joined the community. I can see a lot of people joining the community. But the second link get you into the workshops support channel. I would recommend you to join this. Not only this workshop, all the future workshops will be supported through this channel. Okay, and we will attach this zip file, and the zip file have all these resources. So we have the presentation which I have shared in the form of PDF, the presentation which Naresh is presenting at this time, the Python notebook, and also the data. You have these 4 PDFs. Okay. And I'll also go through the details about what these PDFs contain, and then I'll hand it over to Naresh to give the demo. So if you look at this PDF, this is Toyota Corolla. It is one of the most popular sedan in US, most selling sedan, and it have all the details like overview, engine options, key features, safety, comfort, and technology design, which are under key features, fuel efficiency, pricing, ideal customer, competitor comparison, FAQs, so on and so forth. So it's also a bit nostalgic for me because this is my first car when I landed in US, and I bought a Toyota Corolla. So if I if I look at this, it says ideal customer is first time buyers. Okay, just wanted to share that nostalgic moment. And like this, you also have the other PDFs like Camry, similar, structure is similar. And this is, if you think from the dealership perspective, right? This is a specific dealership's data. And if a salesperson in the dealership wanted to quickly search on top of his data or on top of their dealership's data, then you can't use ChatGPT. You can use ChatGPT application. You cannot use GPT model directly. Okay, I have even demonstrated using custom GPT in our overview session for the cohort. You can even use GPT in ChatGPT, but there are challenges for that also. You'll understand if you sign up for the cohort. Now, from the RAG perspective, this is a simplified example. Using these files, if you wanted to get grounded answers, you have to build RAG-based applications. And we'll be testing the application using these files, and we'll share all these resources in the form of zip file in Discord channel immediately. Okay, so let's pause a minute for a minute, Naresh. Let's see if people have questions. If they don't have any questions, then we'll take it forward. Okay, I think there are no questions. You can take the take over. I'll stop sharing the screen,
Okay.
and you can start sharing the screen and take it further. Meanwhile, I'll share the zip file.
Okay. Yeah, as Durga explained, right? There are certain documents related to a Toyota, and a salesperson wanted a quick information to serve some of the clients. So that's where we are going to build the RAG application, because assuming that these the models don't have the information of the um, Toyota, because those documents related to the Toyota, internal to the Toyota. So we'll share this notebook, and so we need to install certain dependencies. So we have all the dependencies here in place. I think I installed, but I think restarted. So let me install these dependencies. So we need a LangChain and LangChain, because we are going to use the OpenAI. So that is why we have an LangChain OpenAI, and some of the LangChain hub. We don't need it, but these are have some internal dependencies, so I had to install them. And the other important thing is we are installing the Chroma DB. So we wanted to use the open source Chroma DB as a vector store for these documents to be stored. So that's why we are installing the Chroma DB. And
So,
these are
Naresh, sorry, once again, let me interrupt you here.
Mhm.
Let me also share them about how to use the resources. Okay,
Mhm.
and then I'll hand it over to you. So let me share my screen once again. Okay, already I have shared the resources in workshop support channel. You can see. You can download this. Once you download, you will find the zip file like this, right? You just uncompress. Once you uncompress, you will see a folder like this, right? Now the first step is you have to upload this data folder into Colab, and also you have to upload this notebook. It is very, very important. How to do that? Open your browser, go to Google Colab. Okay, you can see here. So you click on this. Okay, it is connecting to the runtime. Yeah, now you see there are files, but the files might go off. There is a way to preserve permanently also, but for this you don't need to preserve permanently. As soon as you see this, you can upload. Okay, how to upload? Let me see. I think this is the one. Yeah, upload, right? Data, click on data and upload. Okay, you cannot upload the folder. So first, let's create a folder by name data. Once you create the folder by name data, yeah, it just took a little bit of time. Now you can actually upload. So now all the four files are uploaded. Okay. You also need to upload the notebook, right? That you can actually go back to the folder which is uncompressed. And then this is the notebook. You click on the notebook and it will open up the notebook for you. And Colab is a free environment. If you haven't used it before, it's free. It is provided by Google, and you can actually start using it. It's pretty powerful also. I don't want to get into all the nuances with respect to Colab, but for now, once the notebook is uploaded, you can double click on it. Okay, for some reason it is not opening up. Uh, Let me see why. Okay. So, any idea,
No, no,
Naresh,
it's
why?
open, Durga. It's open. I think you need to minimize that one, the right side one. Um, I think take out, click on the raw. Yeah, maybe click on this arrow
Okay,
up
how
arrow beside that one. No, no. Maybe this one. Here.
how to close this? Yeah, let me first close all tabs. Now let me open.
Change page layout. I think there is an option change page layout, right? Scroll down, bar down, single tab.
Okay,
This middle part is something that already the notebook only. Notebook view only, middle part one.
but this is a different one.
Oh,
This is
okay. This is a different one. Okay.
yeah. Let me figure it out real quick. Close all tabs. How to close this?
Maybe refresh your screen one time.
Yeah, probably that
Yeah,
could be the.
open that one. Double click on that one. I think it should be
Yeah,
on.
I think I understood now. So you have to upload from here.
Okay.
So now I understood. So whatever I have shown earlier, right, to upload the notebook here, here you can only upload the files. Okay. Okay, to upload the notebook, all you need to do is once you go to the collab, you click on file and then upload notebook and then take it forward. I missed that part. That's why we ran into issues. For some reason, the data folder is gone. Let me create the data folder again. Okay, now let me upload the files. So you have to make sure you upload the files here. Okay, now you are ready. The notebook is on the right side. You can see the files, so and so forth. So this is how you can actually get started. On top of it, one more thing which you need to keep in mind is this keys. You can click on the keys. Okay, and you need to enable them so that the notebook can access. And we have provided all the instructions here to actually configure the keys and all. Okay, so this should be the names of the keys. Here you should have these two, LangChain API key and OpenAI API key. And here you have to come up with the values. So you have to sign up for LangChain, uh, yeah, and then get the API key from there, paste it here as value. You also need to sign up for OpenAI and then get the API key from there and paste here. And then the rest of the notebook you can actually run as demonstrated by Naresh. Okay, once again, I am reiterating the support for this will be provided through Discord so that you are really comfortable. Already you can see there is a workshop support and I have already shared the link also. You can join here, you can download and then you can go through all whole 9 yards to ensure you actually practice. Okay. Yeah, Naresh, now you can take over.
Yeah, sure. Thanks. Okay. Okay, let me share my screen back again. Hope you can see my screen, guys. Durga, you can see, right?
Yes, yes.
Okay. So yeah, I think Durga explained, right? So you need to upload the documents. Yeah, I have uploaded the documents. I have a certain number of documents here, and this is my notebook. And in the beginning, you how to set up this entire environment. So it is there. So once you have that one, so here is the uh, dependencies we required to run this demo. So we installed it. I just installed it. Once you get installed, it will ask the
Yeah.
uh,
Sorry to interrupt you, Naresh, once again. Can you zoom in here?
is good.
Yeah, yeah. Now it is good.
Is
I
good.
think your screen, I am not seeing your screen. Can you share again?
Oh, you're not seeing my screen. Okay.
No, I think I have clicked on something where it made you stop sharing the screen.
Uh, is it okay now?
Yeah, yeah, it is much better.
Okay. So yeah. So this is the instructions Durga explained just now, and these are the libraries we need it. So I installed it. So once I installed it, it will ask to restart the session. I just restarted this environment, so we are good to go. So we will go through this setup. Like as I said, right, we wanted the LangSmith, we wanted to track the all the API calls, database calls, right? So that's why we are setting the certain environment variables like the tracing to be true. And this is a LangChain endpoint. So this is a standard endpoint. So when you sign up for the LangChain, LangSmith, when you sign up for the LangSmith, it will give you the key key for you, so that this is the LangSmith I signed up. There is a free version, we can get it, a certain key. So if you go here and then once you log in here, you will be able to create a key. So this is what I created a key some time back, and I'm using the same key in my demo. Here I'm using the LangChain API key. So it's a free one, somebody's asking, but you can get it, but with limited functionality. And the OpenAI key that you can sign up and you get it. The other setting we need to be look at it is that LangSmith project name. So here I put the project name as a tutorial one. If I go to the LangSmith, I have in a projects, different projects, tracing projects. So I'm using this tutorial one as a project to track all the executions of the LLM uh, when I was running the RAG application. I'll go through them in a minute, these entries. So these are the some of the settings we need to enable it to run our demo and track the API calls. So let me run this one. So I was able to run. So the next step is like we uploaded this document here, right? So these are storing in my notebook, right? So we need to store them into the database, the vector database, so that we can do the similarity search, right? So storing into the vector database is a list of steps. So we load the files, we split them, like the break the documents into small parts, meaningful parts, and then we generate the embeddings and store into the vector store. So that is what this indexing stage. So to do that one, again, the LangChain have a certain library methods to do that one. Here, the documents are PDF documents. So I'm using the PDF document, PDF loader from the LangChain, and I'm reading from the data folder. So here I have uploaded the documents under the data. So I'm reading from the data folder. I'm going through the each file, and I'm creating a LangChain object of list of these files. So that is what is a typical plain Python program anyone can understand. So the next thing is like, so I have a little bit of few documents, so it's taking a minute. It will finish it. Yeah, it finished in 9 seconds. So the next step is that we loaded those documents, right? And we programmatically read those documents, and they stored in the cars object. So the next thing is we wanted to break them into the small parts. So the LangChain gives a different kind of splitting functionalities. So for this demo, we are using the recursive character text splitter. So the recursive character text splitter is basically break your documents into the um, size of 300 characters with the overlap. So to see the visualization, let me show you one example of how the um, how we can do the breaking of these documents. So let me open a minute. Hmm. Just 1 second. Text splitters, text splitter, yes. Yeah. So we are talking about the text splitter, right? So if you see here, this is a online application. You can see that how the chunking will work. So here we gave a set of text, and then we can select a different splitters. So let me do the recursive character text splitter that we are going to use. Here, when I'm specifying that, I'm specifying by, I wanted to break by documents by this chunk size. So this is the text. So you see that when I specify the chunk size, it's able to do the break it into the small parts. So that is what will happen when you do this, when you call this program programmatically. So this is a visualization. You can see that how the breaking will happen. So that is what we happen. So when we break the documents into small parts, we got a splits. Here we are seeing that we got a 29 splits. So here we have the document more, we have a few documents, but when we apply this kind of chunking strategy, we got the 29 documents. We can even see the, let me run this one just to, so we can even see the content of the one split. So the split is basically a list, right? So I'm trying to get the first list. So if you see this one, it is basically an object, document object with a certain parameters. This is the metadata for that one. And you see the page content. This is basically the actually the content from the PDF. So the document object, the splits contains the document object that is basically the page content. So break the page content, and even it has some kind of metadata from which document this text is coming like. So that is what these splits. So once we have the splits, the next step is like generating the embeddings and storing into the vector store. So the LangChain came up with, we don't need to do the two different steps like generating the embeddings and storing. LangChain out of the box do the embeddings, generating the embeddings as well as storing them into the database. So that is what it's do that one. So here we are saying that Chroma from documents, the splits that we created earlier, and we are saying that use this embedding model to generate the embeddings and store it one. So that is what it is doing. So when we run this one, it will read the documents, those are broke, and generate the embedding, store it into the vector store. So it's already stored in the vector store. This is what the vector store object we have it. So that concludes the first step, like the indexing the documents that is ready for our RAG pipeline. So the next thing is the retrieval and answer generation. So that's a second step, two steps in the RAG, right? So where we do that one, so we first retrieve the documents from the vector database that we stored, and then we use those documents to finally generate an answer. So that is what we are going to do. So let's see that one first, how we can, when we retrieve the documents from the vector store, what we are getting. So here I created the vector store, that vector database object, we already have it, right? So I'm getting a retriever from it. Retriever is basically a SQL query engine, like a SQL query client, like the databases have clients, right? So that's what the retriever. So with the retriever, we can pass the questions and retrieve the documents. So when I'm passing this natural language question, you wanted to limit how many documents you wanted to retrieve. We don't want all the documents to be written, right? So that is what the value controlled by the K. This is called the top K. So when I'm retrieving the documents from the vector store for this query, I wanted only the one document to be written. I don't want the more documents. That is what the mean. So this is something you can try with the different numbers for your rags, but for this use case, we put it one. So we are passing the question in a natural language. So when we pass this question to the vector database, it basically do the semantic check, semantic similarity check. It's not an exact search. It will do the semantic similarity. Semantic means meaning of the text. So we are asking in the questions in the natural language, and then it will try to pull the documents in the sense the chunks, the splits we stored, which is having the information related to this price of the camera. So if you see this one, okay, let me run and inspect this one. So I asked the question and I got the document. and I was looking at the document content. If you see this one, it was able to identify the right document. So if you see that one, it was talking about the uh, here somewhere else we have the price of the Camry. Somewhere here, yeah, you see here it has a price related to the Camry. So to see that one, it's basically coming from this document. So you see, when we ask the question, it is able to find the right document that has the information that we are looking, and it was able to do that one. So that is the what this vector databases will do. So these are specialized database. These are not the relational databases that we see today. So they are process the documents, millions of, let's assume that your vector store has millions of documents. From the millions of documents, it was able to identify the right documents within a fraction of the seconds and able to give you the response. So that is the beauty of these vectors databases. So these are the databases required for the generative AI applications. So that's what returning the object. So now that this concludes the step one, like we were able to retrieve the documents. The next step in the RAG is
Yeah,
the generation.
Naresh, sorry to interrupt you. There is one very important question which we need to answer.
Mhm.
It is about Anshul have asked whether here cosine similarity is being used.
Yes, here the get relevant documents, right? There are various similarity techniques, cosine, Manhattan. I don't remember the other techniques. So there are different ones, but most of the times we use the cosine similarity because that gives most of the times the better answers, better contextually relevant answers. Yes, to your question, we are using the cosine similarity behind the scenes. So again, we don't need to do all those things. LangChain will do that for us. All we need to tell it LangChain to do the work, use the cosine similarity, and then it will do that for us. So that is why we use these frameworks. We don't need to write all the boilerplate code for it. So we got the document here, and then so here I'm trying to do a different way. So here I'm doing a similarity search. I'm using a different way to get the some kind of documents. Let's say I'm getting the one document, and I'm trying to see the similarity score to the question, like the question I was asking to the document that retrieved. What is the similarity? This is the similarity score. So this is related to the cosine similarity score. When it do the comparison of our question with the documents, this is the similarity score generated for it. So that concludes the first step. So the next step is, so we have the, now we retrieve the documents. Those documents probably answer the question that we are looking. So the next thing is like create a prompt. So if you look at the prompt, we are saying that answer the questions based only on the following context. So the context is the one we retrieved it. So we retrieved in the previous step, right? We pass that context here, and we are telling the LLM answer the question using the context below. And also we are restricting the model. If the context does not contain the information related to the question, don't answer it. Saying that I don't know. We don't want the model to give its information from its own knowledge base. We want always the model to answer from the information that we pass, right? So that is the reason we are putting the prompt in such a way that mm, it give the information that you are using. So that is what the prompt we built it, and that is what the chat prompt. So once you build the prompt, we are going to define the model for our application, drag application. So here we are going to use the OpenAI application, chat OpenAI, and GPT-4 model. And we set the to use this model, we need the key, right, that we set in the beginning of the notebook, right? So it was able to use those credentials to do that one. So once you've done that one, to build the RAG chain, it is so simple with the LangChain. So you just need to build the components. Like you need to tell that one, get the information from the retriever, replace in the context, and you question whatever the user asks, that one you put it in the question place in the prompt. So basically we build this uh, string with the context replaced with the information that retrieved and the question with the user question that passed. So that is what the meaning of this line here. So that we are passing the prompt, the information from here, these two variables will go into the prompt, and the prompt get replaced with this context and question, and then this prompt will be passed to the LLM. That's what it is. And we are going to parse, the LLM will generate a response, right? So we wanted a human readable format, so that's what, there is a different parsers the LangChain giving us. So we are passing the parsers to generate an answer for us. So let me, okay, did we run, okay, we did not run this prompt. So we ran the prompt, and then we defined the LLM. We are using the OpenAI GPT-4, and then let's run the, okay, string. I Give me a second. Give me a second.
You need to import. You just have to
Yeah,
import
import.
from.
I forgot that import statement. Just copy pasting it. Oh, there is that. Uh,
Actually, it is in the next. Uh,
no, no,
go to
it's
the yeah,
okay, okay,
that
okay.
string output parser. Yeah.
Okay, okay. Yeah, thank you. So here is the thing.
Yeah. So one more thing, guys.
So
So here, even though the core content is generated by Naresh, I wanted to highlight ITVersity involvement also. This is primarily to motivate the other aspiring aspiring speakers who wanted to leverage the ITVersity brand and promote yourselves also. In case if you wanted to collaborate, we'll work with you closely to ensure the material is up to the mark. We'll come up with the real-time examples or real-life examples, and we'll make it a lot more effective because it's an investment of time from our audience also, and we need to respect that, right? So feel free to reach out to us in case if you want to be speakers, and we will definitely work with you to take it further, and we'll give world-class experience for our audience.
yeah, yeah, yeah. This is just I'm just providing, but it's all the Durga and his ITversity is the material that one. So yeah. So this is the
No,
so
no,
we
sorry. You are so humble, Naresh. If you are not there, I wouldn't have taken this up seriously.
no, no, that's
Okay,
fine.
I'm just complimenting your efforts a little bit. Go
Yeah, yeah,
ahead, yeah.
yeah. Good. So here we are defining the chain. So we are defining the prompt, and we defined our RAG chain basically. So this is the way you can do that one. There are different ways to do that one, but this is the very simple way so that you can quickly get started that and get a feeling of the RAG. So once we have that one, so this is the way we can invoke the RAG. So here I'm asking the question like, what is the price of Toyota Corolla? So it was able to give the documents like it went to the data, it used the information that we retrieved from the vector database, and it was able to generate an answer. But how do we confirm that it's used that information of that retrieved information? So to do that one, you can go to the LangSmith. I'm in the LangSmith screen, and this is the one project I was using. So if you see here, I asked the question,
Yeah,
right?
can you
So
zoom in a little bit, Naresh?
okay, okay,
Yeah,
it's
thank
good,
you.
no?
Yeah,
Yeah. So I went to the LangSmith and I asked the I logged into the, so I went, okay, let me do that one. I'm the my LangSmith screen. This is the project we used it. And if you go and see that one, the first entry, this is what we just asked, right? So if you see this one, when I run this one, there are certain steps happen. So what happened? First I'm asking the question, input, and this is the answer I generated, right? But to see that one, how that answer generated, let's go and see these things. So here, when I asked the question, we retrieved these documents. These are the documents. We retrieved only one document because we set the top K as one, right? So that is why it retrieved the document that contain the information of the Camry prices, and it uses that information to generate an answer. So you see that vector calls happening, and output of the chart completion output, the answer generated by the LLM. So this is the answer generated by LLM, but the parser, right? The final parsers parse this response and gave us a good human readable format. So this is an output. We made a call to the GPT-4. So that's what we are doing in our code, right? GPT, we use the GPT-4 model. So where is that? Yeah, here we are using the GPT-4 model. So all this information you can find it, like it's an observability platform. Let's say if there is any failures, you can come here and what happened in your RAG pipeline and able to debug all those things. This is super powerful. A lot of for enterprise applications leverage this one to try debug the issues in the production. Okay. So that's where you can ask the question. So let me ask a different question here. Maybe I'll ask the Camry question now. What is the price of the Camry? So let's see that if it gives the price for the Camry. Yes, it was able to give the prices of the different models, LE model, SE model, and XSE. So these are the so the here the LangChain is able to answer the information from your documents. Let me ask a question. Let's say most of we are from India, right? So we know that Innova is a very good car in India. So let's ask the question of Innova and see that what our RAG pipeline will say that. So technically, we don't have any information related to the Innova in our documents. So let's see that what it will give that one. It's going on, executing, because it was trying to see the information. So here, yeah, it came. See that it's trying to. You are asking a question, but it was saying that I don't have the enough context to answer the question. So the behavior we are driving because of the prompt. The the way you prompt your RAG prompt, the way you define your RAG prompt will dictate the output of your RAG response. So that's what here you can you don't want your RAG system to answer a question that's not relevant to it. So that's how you can control that one, and it's basically help you to define the scope for your application, LLM application. Let's say you built in a chatbot for finance. You don't want to answer any some kind of HR kind of thing. So that's where you can do that one. That is the beauty of these um, uh, prompt techniques, prompt engineering. You can do that one, and the RAG is the way help you to achieve that functionality. So here I'm running a few more questions to see how it is going to return that. So I'm asking a few more questions. Uh, okay, yeah, I think it's generating that. So it's able to generate those questions, all those questions. You can do the batch. In the batch, you can ask, and in the LangSmith, when you go here, you can find all the information related to your the things you asked. So this is the way here. Observe this one. Here I'm seeing that I use the 430 tokens, and this is the cost happened for me, and this is the number of total tokens. And I think I ran for 28 times this pipeline so far. And this is the cost. It's a very minimal, lot of information, overwhelming information. You can find it from the LangSmith. So that so this is the main demo we wanted to cover. So it's a this LangChain will help us to build this application seamlessly with a lot of knobs and knobs. You can fine tune them. So this is what I wanted to cover. Durga, I want. Do we have the time to go over back to this advanced techniques? or like we'll.
No, that is fine. I mean, we'll share the presentation and they will get an idea about the advanced topics. I think we can wrap up. Most of the questions are answered. If people have any specific questions, I will be there for 5 more minutes. And as I mentioned to you, I will take this chat. I'll export this chat, and for all the questions, we'll respond through email. And also, we'll share a detailed document in Discord also. That way, most of the questions are answered, right? But still, we wanted to take a couple of questions here. And before taking up the questions, I have just shared a LinkedIn post which I have posted, and especially it will be very motivating for us. Sorry, not this one. I'm sorry, I shared the wrong one. I have to share the link to LinkedIn post, not the YouTube video. So the YouTube video is also there in that LinkedIn post, and I want you folks to means it's not a demand, it's a request. It will be great if you can actually like, comment. Okay, 1 minute, it is still not working. Fine. So it will be very motivating for us because shit, why it is not copying properly? 1 minute. Copy link to post. Let me paste.
But I really appreciate the folks. It's a late in India, but you still show up for this one. And we appreciate your efforts as well.
Yeah, just give me a minute. I'll just share this link. I don't know. It is not letting me to. Yeah, I think I know. Let me. Yeah, now I'll share the link. Yeah, I shared the link to the post. It will be great if you can like, comment. I'm looking for your comments for the feedback, and also repost so that it have better reach. And as I have mentioned to you earlier, we'll be conducting a lot of such events, and it will be motivating factor for us. Okay. So that being said, thank you very much, Naresh. And once again, it's more than Naresh. It's you who made it success, and it's a great response for our first meetup, first of its kind meetup after a very long time, and we will continue doing this. And Avinash, we not only shared the notebook, but also all the resources in Discord. And you can actually join our Discord community and also sign up for the channel related to free workshops. And already the details shared there. So you can download and you can take it forward, and also you can ask the questions through Discord. And Shiva, who shared who responded for few people, is going to provide the support, and even Naresh and I will act as L3 support. Okay. So that being said, one more thing which I wanted to highlight before we wrap up is the meetup feedback, because I want the meetup community to be at least 20,000 by the end of year 2026. As of now, it is close to 1900, and the more feedback you give, it will be automatically be promoted. Okay. Uh, Rishikesh, all these questions will be answered, and for now, we'll sign off. Once again, thank you very much for all those who joined this session, and also thank you, Naresh. It's really wonderful. And we'll collaborate. Means if you wanted to be a speaker, feel free to reach out to us. We'll collaborate, and we will make our dreams reality. Okay. Thank you.